Hello everyone. In this session, we are going to control the rotation, speed, and direction of DC motors using an Arduino attached to an L298N motor driver. Before we begin, we should have the following components ready. First, we need the Arduino Uno with a blue USB cable. Second, we need the L298N motor driver. Third, we need two geared motors. Fourth, we need the battery case and 4 AA batteries. Just like before, do not attach the batteries yet. Fifth, we need the following jumper cables. 6 female-to-male jumper cables. 1 male-to-male jumper cable. You can use any color, but using different colors may make it easier for you to wire the components later. Lastly, we need the screwdriver to turn the screw terminals on the motor driver. Before we continue, let's summarize what we learned from the previous session. First, a DC motor speed can be controlled by changing the voltage applied to it. Second, a DC motor's direction can be controlled by changing the polarity of the voltage applied to it. We also learned that controlling the voltage on the in pins on the bottom part of the motor driver changes the direction of rotation of the motors, following the tables here. Today, we're going to learn how to control the speed of the motors using the enabled pins A and B on the motor driver. For that, we need to use PWM or pulse width modulation signals to control the pins. So, what is pulse width modulation? Pulse width modulation or PWM is a series of on-off pulses with varying duty cycle. A 0% duty cycle means that the signal is off 100% of the time. A 25% duty cycle means that the signal is on 25% of the time, but is off 75% of the time. A 50% duty cycle means that the signal is on 50% of the time and off 50% of the time. A 75% duty cycle means that the signal is on 75% of the time and off 25% of the time. Lastly, a 100% duty cycle means that the signal is on 100% of the time or all the time. So, how do we produce PWM signals? Of course, with our Arduinos. As mentioned in our past sessions, we can get PWM signals from the digital PWM pins of the Arduino, or those with the tilde symbol. These are pins 3, 5, 6, 9, 10, and 11 on the top row of the Arduino. To get PWM signal from these pins, we type analog write, open parenthesis, the pin name, the value from 0 to 255, and the closed parenthesis. For example, if we want a 0% duty cycle PWM signal, we type analog write open parenthesis, the pin name, comma, 0, then closed parenthesis. If we want a 25% duty cycle PWM signal, we type analog write open parenthesis, the pin name, comma, 64, then closed parenthesis. If you remember, the analog write function accepts the values from 0 to 255, corresponding to 0 and 100% respectively. We got the number 64 by getting 25% of 255, which is around 64. For 50%, 75, and 100% duty cycle, analog write will be written as follows. Since the Arduino can produce PWM signals, we can use it to control the motor driver. Let's connect them together so we can have more advanced control of our motors. But before we proceed, get your tools and materials ready because we will start wiring the components together. Let's start first with the motor driver connections. Get your motor driver, the two motors, the battery case, and screwdriver. Attach the left motor wires to the left screw terminals. Then, attach the right motor wires to the right screw terminals. Then, attach the red wire of the battery case to the positive or leftmost bottom screw terminal. Then, attach the black wire of the battery case to the negative or middle bottom screw terminal. When you're done wiring the motor driver, connect the jumpers between the Arduino and the motor driver. First, you have to remove the jumper caps from the Enable A and Enable B pins by pulling them out. Then, using the male to female jumper cables, attach the following Arduino pins to the motor driver pins. Connect the Arduino pin 6 to the driver pin Enable A. Then connect Arduino pin 7 to the driver pin in 1. Connect Arduino pin 8 to the driver pin in 2. Connect Arduino pin 9 to the driver pin in 3. connect the Arduino pin 10 to the driver pin in 4. Then, connect the Arduino pin 11 to the driver pin NB. Lastly, we have to make sure that the ground of the Arduino is connected to the ground of the motor driver. This is called common ground. We can use the male-to-male jumper cable for this one. Loosen the negative or ground screw terminal on the motor driver, then insert the male jumper in the terminal together with the black wire of the battery case. Once both wires are inserted in the negative screw terminal, tighten the screw and tug on the wires to make sure that both wires are properly secured in place. If they pull out, do it again. Maybe you can twist the wire a bit around the male jumper. Then, insert the other end of the jumper to one of the ground pins on the Arduino. Once you're done connecting the components, it would look like this. Please double check all the wiring to make sure that all connections are correct. I uploaded the 3 screenshots of the wiring in our Google Classroom so you can refer to them. It's time to upload the code to the Arduino. I uploaded a file entitled Arduino L298N test.ino to our Google Classroom. Download that file, then double-click on it. Arduino IDE will ask you to create a folder containing the file. Just click OK. I recommend that you save the sketch file into your Arduino folder so that you can easily keep track of your files. Click on File, then Save As, then choose your folder, then click Save. Attach the USB cable from your computer to the Arduino, then upload the code. Just like before, if you encounter problems uploading, check if the port in the Tools menu is correct. Once the code is uploaded, we can insert the batteries into the case. But do not remove the USB cable from the Arduino to keep it powered. The motors may start turning the moment you attach the battery. Observe first if the motors are behaving as expected. If one of the motors is rotating in the opposite direction, you can either flip over the motor or you can swap the black and red wires of the motor on the screw terminals. If one of the motors is not turning, maybe the jumper is defective. Try swapping out the jumpers for another set of jumpers. Once you are done with the testing, remove the AA batteries from the case to conserve energy and to be safe. Just like in the previous sessions, you have to submit a short video showing that the system is working as intended. So after this class, do not dismantle the system as you will still take a video of it. But please remove the AA batteries. Furthermore, we will be using the same system in the next session. Therefore, I suggest that you keep the assembled system in a box or other container so that it will still be intact when we work on it in the next session. Once again, thank you for following along and see you in the next session.